In the United States, over 100,000 people are waiting for an organ transplant, and every day about 17 of them die. This shortage doesn't just cost lives, it leaves families waiting, hoping, and often running out of options. That's why scientists are turning to new solutions like 3D printing organs. They use special printers along with the material called bioink, which is made from living cells mixed with supportive gels and nutrients. It's designed to keep the cells alive while the printer stacks them into layers. The idea is to create structures that don't just look like tissues, but can actually function, grow, and even connect to blood vessels once implanted. Think of it like building with Lego bricks, only the bricks are cells and the goal is to end up with something that works like a real heart or liver. One approach is called biomimicry. That's basically like following the Lego instructions exactly. Every single cell is put right where it would be in a natural organ. Scientists try to recreate everything: the layout of the cells, the protein scaffold between them, even the tiny blood vessels that carry oxygen. If they can pull this off, you'd have a near perfect copy of an organ. The challenge is printing billions of these cells in just the right spots, with the right materials while keeping them alive. The other approach is called self-assembly, and it's more like how organs naturally form in the womb. Imagine Lego bricks that click together on their own without anyone touching them. Cells can actually sense each other, communicate, and arrange themselves in tissues. In labs, scientists use clusters of cells called organoids or spheroids, which naturally fuse and grow. Scientists are already using organoids to model many versions of human brains, kidneys, and intestines for research. With this method, you don't tell every cell where to go, you just create the right conditions and let biology take over. Both methods have their own perks. Biomimicry gives us control, self-assembly taps into biology's own genius, and now researchers are finding ways to merge the approaches. For example, at Harvard's Wyss Institute, teams are 3D printing larger vascular channels while also working to integrate self-assembled capillary networks. Progress like this shows the field isn't science fiction anymore. We're moving toward a future where organ shortages could be solved not by waiting for a donor, but by printing the cure.